Okay, so this is section 6.3 from the Blumen ninth edition, and we're doing number 7. It's right here. Okay. So unemployment rate benefits. So the average weekly unemployment benefit in Montana is 272. So we need to realize that this is our mu. And the reason is that it's talking about the whole population of people in Montana rather than just a sample of people from that area. So our mu is going to be 272. It says suppose that the benefits are normally distributed with a standard deviation of 43. So again, because this is a population, our standard deviation is actually going to be denoted by sigma, and it's going to be 43. It says a random sample of 15 benefits is chosen. So that means my sample size is 15 because it says a random sample of 15 benefits is chosen. What is the probability that the mean for the sample is greater than the US average, which is 299? So basically we're looking for just the probability that my mean is greater than 299. Okay, that makes sense. Don't be like worried about like, oh, the US average, like how is that playing in my calculations? It's not gonna be your mu. However, it will be in your calculation as your sample mean. Now I'll explain that in a second. So, when we're now we're looking for a probability. Usually it's gonna be the area underneath the normal distribution curve, especially when they tell you that the data is normally distributed and they ask you for a probability. They're just asking you for the area underneath the curve. Okay, so this is usually you'll get a z-score and then you go to your table and find all that and find the probability using the table, like the edges. So what we're doing is the same thing. Usually z is equal to some data value minus r mu divided by r sigma. But this is no longer, we're not just using a normal distribution of the data, rather we're using a distribution of the sample means, and that's why we now use x bar minus mu, and always the standard deviation when we're looking at a distribution of the sample means has to be sigma divided by the square root of n. Okay, so this is just the formula for this. It's very elaborate. It's elaborated more in the book underneath. I think the section was called central limit theorem, or the portion of it. So yes, so we have this. Okay, well, remember when we used to have like, oh, we need the probability that x is greater than some value, like let's say 80 or something, and we say z is equal to x minus mu over sigma. This 80 would come to would replace the x, and then in this case where it's really not any different. We're looking for the probability. Okay, so basically when we're looking at the normal distribution, we know that our mu is 272, and we want to see if x is greater than 299. So 299 would be somewhere around here, and we're just looking at this portion right here. Okay, so we just put 299 into this x. So we end up with 299 minus 272 divided by 43 divided by the square root of 15. So with a little bit of calculator magic, we would get 299 minus 272 divided by 43 divided by square root of 15. We end up with 2.43. Really, we don't need any more than 2 decimal points due to the nature of the z-score tables. Okay, so we found our z-score, so that's good. Now we need to go to the table. Let's go to the positives table, which is right here, and we're looking at let me check again. It was 2.43. We're looking at 2.43. Okay, so now let's just go to 2.4 and let's look at here. So it's gonna be 0, and they meet right here at 0.0925. Or actually, I think it's 0.99. Am I reading this wrong? Yeah, 0.9925. Okay, so now we know that the probability, we need to remember one big thing. What this just gave us, the 0.9925, oh sorry, I don't know, I wrote X, I meant Z. This is not the probability to the right, because that's not what the table gives you. The table only gives you the probability to the left. So this really is just the probability that we are less than, what was the Z? 2.43. 2.43. So there is a 99.25% chance that I am less than 2.43 for Z, which means I am less than $299. That's a really big probability. So the probability that I'm greater than that is just going to be 100%, right? Minus 99.25 to give me 0.75%, which is written as 0.0075. And this is going to be our probability that Z is greater than 2.43 is equal to the probability that my sample mean is greater than $299, and it is 0.0075. Another way to think about it, this whole graph from negative infinity to positive infinity, it's all, the area underneath it is 1, because 100% it's going to be somewhere between negative infinity and positive infinity. And we want it to be at 299. So basically it's going to be somewhere around here. Let's say this is 299. We're looking from here to infinity, right? So isn't that just this line? If I take away this portion right here, if I take away this portion, so you can think about it as this is 1 minus, we know that this portion is what? It's the purple area, which we found to be 0.9925. So it's going to be 1 minus 0.9925 to give me 0.0075, which is the same answer. So yeah, this is it. Thank you guys.